From ContainerDays Hamburg, this video is proudly presented by DuxIT.
So today we are going to talk about the future of Kubernetes networking, and more specifically regarding workload and container exposure externally on the internet. So let's start with a quick intro. I'm Emile Vauge, the creator of Traefik, popular open source reverse proxy. Also the founder of Traefik Labs, the company behind Traefik. And I'm the CTO of this company. I'm also a member of the Kubernetes SIG network, GatewayAPI work group that makes these specs possible.
And I'm Romain Tréboté, Traefik Maintainer and a senior developer at Traefik Labs.
All right, so the first question is, why do we even need a new specification for Kubernetes as we have already Ingress? So to understand that, let's go back to the very beginning in 2015, which is 10 years ago. So feels like yesterday, but a lot happened since then. So this was the rise of microservices in 2015. This was the year Kubernetes was created. This was the year Traefik was created as well. With the birth of Kubernetes came a critical need, workload and pods exposure on the internet. And to solve this problem, the Ingress specification was introduced this same year. And the purpose of the Ingress spec is very simple. Expose HTTP workloads in a standardized way while being neutral to the different vendor implementations. So this was great on paper because the spec was focusing on one thing, being simple and focusing on one use case. So you can clearly define HTTP routes with basic rules and TLS. So this works very easily, and it explains why the Ingress specification has become the standard and is so widely used today in the Kubernetes world. And indeed, if you strictly stick to the spec, you get vendor-neutral resources. For example, on the left, you have an Nginx resource, and on the right, a Traefik Ingress resource. And the only thing that is different is the Ingress class, which is obvious. So the migration is pretty easily, right, between different Ingress controller. However, when you face reality, things quickly get more complex, and you quickly want to move from the basic use case. Of course, HTTP is the most common use case, but what about TCP? What about UDP? If you want to use MTLS to mutually authenticate clients to servers, you can't. At least it's not in the scope. If you want to have authentication with JOT, it's not in the scope. If you want to have advanced matching rule, if you want to have advanced traffic management like rate limiting, retries, canary, which are a much needed feature for microservices, it's not part of the scope as well, right? And the list goes on. And finally, there is one key issue, which is the lack of separation of concern. Platform teams and engineering teams are forced to use and to share the same Kubernetes resources, and while having different responsibilities. And that's a big issue on the security aspect. So we still have a workaround with Ingress, right? Annotations, so basically key values. However, when you see the list of available Nginx annotation, that's the list, right? And if you count quickly, there are more than 100 of them available. So it feels like you're within a cockpit of a plane, right? And annotation, key values, is probably the worst configuration possible, right? It's unstructured data. It's not possible to validate with a schema, right? It is insecure, error-prone, and extremely complex to handle at the end of the day. Let's see with an example, right, what it means in reality. It's a very common use case, right? We want to have an ingress with MTLS, sticky sessions, and calls management. So let's first start with Nginx. And if we want to enable MTLS, then we already have 4 different annotations. If we want to have sticky sessions, let's add 5 more to the bucket. And if we want to have calls, then 3 more. So you already need 4 slides of annotation to implement a really common use case, right? So yeah, you understand that it's quickly complex and unmanageable. Let's see the same example with Traefik. So with Traefik, we have a slightly different philosophy because we try to avoid annotation, but we still have a few of them. So for sticky sessions, for example, we still use them. So that's kind of similar to Nginx. But for MTLS and calls, we use custom resources. So this is the TLS part, which is a structured resource, and same thing with the calls. So yeah, the Ingress spec is simple. The simplicity of the spec made it widely used. However, the original goal of the spec to be vendor neutral failed, clearly, because all the Ingress controller have tons of annotations or way to extend the spec because it's so basic. So at the end of the day, you end up being locked in, right? Which is the total opposite of the initial goal. And additionally, annotation, as I said, or unstructured data, they cannot be validated with a schema. So it brings a lot of complexity to maintain and to migrate. So to solve this unstructured issue and the rendering, including the vendors, including Traefik Labs and Contour, introduced custom resources in 2019. Because we wanted to move away from the annotation. So for example, Traefik introduced the IngressRoutes. So basically, IngressRoutes CRDs bring all traffic configuration within Kubernetes resources, which are structured. And same thing with Contour, which introduce HTTP proxy resources. So great, structured resources. That's powerful. However, it's still vendor specific, right? No possibility to have vendor migration because each vendor has its own CRD. So that's exactly when GatewayAPI kicks in, right? A work group was created in 2019, and at that time it was called Service API, and then it became eventually GatewayAPI. And it took 4 years until the end of 2023 to become production ready to V1.0. The goal was very simple: solve the issue that were raised with Ingress. So basically, the what I said with the unstructured data and the vendor lock-in. And the goal was to prepare for the future of Kubernetes networking for the next 10 years. So yeah, 4 years. It was a long road, right? But the result is very powerful and interesting. Let's do a quick overview of the spec. So the Gateway API spec is based on a strong foundation. Separation of concern, one. Advanced use case support, not only basic, and extensibility. So separation of concern, it means that in a real-world organization, you have different teams, platform teams, developer teams, and they have different roles, permissions, different responsibilities. And what is great with Gateway API is that you have different resources that can be accessed by different teams. So the platform teams focus on the infrastructure resources, and the developer teams, which are gateway class and gateway resources, for example, whereas the developers focuses on routing focusing resources, so HTTP route, TLS route, this kind of stuff. So this separation enhances a lot the security and the maintenance of Kubernetes clusters. And if you compare a basic Ingress resource on the left to the equivalent of using Gateway API on the right, of course, you notice one big difference. It's fully structured on the right, while you have annotation on the left. So you get the idea, right? You can have advanced use case and separation of concern with Gateway API. So that's a huge move for the Kubernetes world. All right, so this was a quick overview of the history of this specification. I will hand over to Romain to deep dive into the concept.
Thank you. So Emile presented the history and limits of Ingress. Now let's dive into the concepts of Gateway API. We'll go step by step through the main resources, the controller, the gateway class, the gateway itself, and the different types of routes. We'll start with resources managed by ops teams. These are the components that define and secure the infrastructure side and are usually provisioned and controlled by platform or operation engineers. So a gateway controller is a component that actually implements the Gateway API specification. You can think of it as a reverse proxy that understands and applies Gateway API resources. There are many implementations. Here are a few examples, Traefik, Envoy, Nginx, Kong, and Kgateway. To qualify as a gateway controller, an implementation must support all the core features of the spec. Beyond that, it may also implement extended features, which are optional but standardized in the spec. And of course, vendors can still provide their own custom extensions. Every gateway controller can be validated using the conformance test suite, which runs against each release of the spec. And this tells you exactly which features a controller support and helps you choose the best controller for your needs. We'll use Traefik today for our presentation and demo. Traefik began supporting the Gateway API early on, back in October 2020, with the very first V1 Alpha 1 version of the spec. And as of today, Traefik supports the latest release, which is the V1.3. To install Traefik with Gateway API support, you can use the Traefik mchart. The critical option here is the Kubernetes gateway.enable true. This enables Kubernetes gateway provider in Traefik. And along Traefik, the mchart will install for you the standard set of Gateway API CRDs, a default gateway class which is associated to the Traefik service it deploys, and a default gateway resource. But often, the gateway resource is not needed, and the gateway.enable flag can be used to prevent Helm from creating a default gateway, leaving the control in the hands of the ops team. After installation, you can check the Traefik deployment. You'll see the configured entry points. You'll notice the provider.kubernetes gateway flag, confirming that Traefik is running as a gateway controller. And now we can take a look at the gateway class. It plays the same role for gateway that Ingress class did for Ingress. In other words, it abstracts the implementation of the gateway controller, and gateways reference it. Let's look at the gateway class definition. Like all Kubernetes resources, it has a kind and a name, but unlike most, it's cluster scope, so it has no namespace. The key field in its spec is the controller name. In this example, it is set to traefik.io/gateway-controller, which registers Traefik as the gateway controller. And that's all it takes. Now, any gateway that references this class will be managed by Traefik automatically. Optionally, a gateway class can include parameters ref. This points to a controller-specific configuration object. Different controllers can define their own resource types here. For example, some might expose implementer-specific settings. This makes the gateway class extensible for vendors. So we've just seen the ops resources, the gateway controller and the gateway class. Now let's move into the DevOps resources, the gateway and the listener. A gateway is the entry point into the cluster. Every gateway must reference a gateway class to define which controller will manage it. And the gateway is also the resource that routes attach to. So you can think of it as a bridge between the external traffic, the controller implementation, and the routing rules. One powerful feature of gateways is that they can restrict which routes are allowed to attach. So you can limit routes by namespace, by label, or even by route type. This is essential for multi-tenancy. Ops can ensure that only the right teams or workloads can bind to specific gateways. Let's see how to define a gateway. First, we need to bind it to the gateway class. Here, the Traefik gateway class we created earlier. At this stage, it doesn't expose any entry point. So next, we extend the gateway by adding a listener. A listener is a key concept. It defines a single entry point into the gateway and the conditions for which routes can attach to it. On a listener, you need to define the ports through which traffic is accepted. Along with the port, you also need to configure the application protocol accepted by the listener. At layer 7, that could be HTTPS or HTTP, and at layer 4, you can use TCP, TLS, or UDP. You're also expected to define a hostname or SNI for TLS traffic. Only routes that match this hostname will be allowed to attach. This prevents accidental exposure by making sure a route can bind to the wrong listener. By default, the kinds of rules that can attach to a gateway are determined by the listener protocol. As well, by default, only routes from the same namespace as the gateway can attach. But you can override this with the allowed routes field, which is with this you can allow routes from other namespaces and even control the types of route allowed. For example, in this definition, only HTTP routes from namespace labeled access public can attach. Compared to Ingress, this is a big improvement. Instead of everything can attach everywhere, we now have fine-grained controls. And this is also what makes multi-tenancy and secure separation of concerns possible in GatewayAPI. What about TLS? A listener has a TLS section, and this is how we enable and configure TLS. There are two modes. The first, terminate. The gateway itself presents a certificate and completes the TLS and check. This is the classic HTTPS scenario. The controller decrypts traffic and can apply HTTP routing rules. And the other one is the pass-through mode, to let the proxied service handle the TLS and check. And this only works with the TLS protocol. In terminate mode, you can, of course, specify which certificate to use by configuring the certificate refs field. This points to a Kubernetes cluster that holds the TLS certificate and private key. So we've just seen the DevOps resources, the gateway and the listener. Now let's move to resources that application developer will typically manage, the routes and the filters. Routes define how traffic is routed to services with matching rules, and they also support operations on requests and responses. Another important point is that the routes are protocol oriented, so they are HTTP route, gRPC route, TCP route, TLS route and UDP route on the experimental side. We'll focus on the HTTP route today. When defining an HTTP route, the first thing you specify is which gateways it attaches to. That is done with the parent res field. A single route can actually be attached to several gateways, which is useful if you expose the same app through different entry points. Then an HTTP route defines host names. They are matched against the HTTP host header of the request or the TLS server name indication in case of TLS. A route can only attach to a gateway if its host names are compatible with that gateway. Beyond host names, the matchers lets you target requests based on the path, header, HTTP methods, or query parameters. This example shows how to route only requests on /API with the gets method and that include a specific version header. Matchers can be combined, so you can build quite complex logic. After defining which request to match, the route specifies the backend to reach. Backends are usually Kubernetes services, and you can list several of them and even assign weights. For example, you can split traffic between two services to perform a canary deployment. This makes advanced strategy possible natively without relying on controller tricks or annotations. Finally, a route can apply filters. Filters are operations performed on the request before it reaches the backend or on the response before it returns to the client. This is where you can inject or strip headers, rewrite URLs, add scores, policies, and transform responses. GatewayAPI defines a first category called core filters. These are mandatory. Every gateway controller must support them. A simple example is header manipulation. Adding, removing, or modifying HTTP headers is part of the core. The second category is extended filters. These are also defined in the specification, but they are optional. Each implementer decides whether to support them. For example, URL rewriting is part of the extended set. Traefik implements it, but another controller might not. The third category is extension ref filters. These are not part of the GatewayAPI specification itself. They are controller specific. For example, in Traefik, all the existing middlewares like rate limiting or authentication can be used as extension ref filters. Let's recap the full request flow. A request first arrives at the gateway controller. According to the gateway resource, if the request is allowed, it is passed to the routes attached to this gateway. The route checks it match rules, path, host, header, etc. And if it matches, applies any filter that is defined. Finally, the request is forwarded to the backend service, and this model makes the flow explicit and structured instead of the ad hoc behavior we had with ingress annotations. Now, let's watch a short demo video showing how to expose a service with an HTTP route. So first, we need a running Kubernetes cluster. We also need a gateway controller, so we will install Traefik with the mchart. We need to disable the Kubernetes egress provider, enable the Kubernetes gateway provider, and disable the default gateway resource it will create otherwise. Then we will apply these resources, and once it reports the traffic has been deployed, we can check the gateway class the mchart has created. And for that, we will use the gateway_cuttle command. It's an alternative command to the kubectl command, but specific to GatewayAPI that displays additional and useful information in that context. So we can see that the gateway class has been created. So the condition is accepted, so it has been accepted by the gateway controller, by Traefik. And we can see that there is no attached gateways yet. This is expected because we didn't deploy any. So let's do this. But first, we need a service to expose. So here is a deployment of a simple UMI web server that is listening on port 80. This web server will reply in the response the request header it receives. It will help us at the end of the demo. Then we create a gateway. we make it in the Traefik namespace, and we make it point to the gateway class that abstract Traefik as a gateway controller. Then we add a listener named web on port 8000, and we make it expect HTTP protocol. Then we make it accept root for any subdomain of docker.localhost and any root from the same namespace. Then we create the HTTP route. So the HTTP route will be in the same namespace, Traefik. It will reference the gateway, and it will listen for the domain whoami.docker.localhost on path /demo. It points to the whoami web server we will deploy, and we add a custom request header modifier filter to add a custom header for the demo. Then we will apply those resources, and once they are applied, we can check again the gateway class. We can see that now it has a gateway, the gateway we just created, that is attached. We can check the gateway as well, which we will see has been successfully created, and in its condition we can see that it has been accepted and programmed. And the same for its listener, the web listener, all the condition shows that it has been resolved and programmed. We'll see also that in the attached route, we have the route we just created, and this points to the Traefik whoami web server. So now we are ready to try it. So let's do a request to see if we can reach the whoami service. And tada, it works. And we have the custom header we added on the request. And that be all for the deep dive in Gateway API resources. Thank you.
All right. Let's briefly talk about what's next in this spec. First of all, as you understood already, Gateway API is divided in two channels. The standard channels, which is production ready, and we also have an experimental channels, which is still being actively developed. And there are still some important features that are not production ready, but only available in the experimental channel. As an example, MTLS with backend servers is still in the experimental channel. The stickiness management, the core management, and the backend TLS policy are still in the experimental channel. However, it's moving very fast. The existing production-ready version is v1.3, and the next one, v4.0, sorry, is right around the corner. And the RC1 will probably be available next week. And backend TLS policy will move from experimental to standard, right, during this release. It also brings new another features like supported features, default gateways, etc., etc. So yeah, this is moving very fast, and a lot of contributors are creating PR every day on this spec. So even if there are still experimental features, I think we can safely use it. All right. So yeah, thanks all of you for listening to this very dense presentation. I know it was a lot of information, but as you can see, this is very critical to all Kubernetes users in the community. So as you understood, Gateway API is not only about the future, but it's already in the present. It's already here. It's already production ready. In our opinion, every new project, if we are starting something new on Kube, we recommend to 100% to use Gateway API instead of Ingress, even though you have to enable the experimental channel. I think it's fine. most of the time. It does not mean that it will disappear if it's in the experimental channel. It might evolve in the future. That's it. So yeah, instead of planning a migration from Ingress to GatewayAPI in 2 years, you can start with GatewayAPI today, and you will be safer. Thank you very much.
Thank you.
The first one being most Helm charts still support only Ingress. Now it's the second one. When do you think this will change? Would you still switch to GatewayAPI if this not happens?
So yeah, maybe I can answer this one. It depends on the product, the vendors, right? Because Traefik supported early on the GatewayAPI spec, the M chart evolved also quickly by supporting it, and we cannot really answer for other implementers. It's upon every implementer.
True. What's the difference and advantage between GWCTL describe to kubectl describe gateway my gateway?
Okay, it's mainly at the end of the describe output command. You will see the attached resources to each resources. So it's the additional value.
Thanks. Is it possible to have Ingress Controller and Gateway Controller enabled at the same time?
Yeah. No issue.
Perfect. That's super fast answering questions. Does migration from Ingress to GatewayAPI works fluently with Traefik?
Excellent question. So yes, however, it's not perfect, and it's not perfect with any Ingress controller yet. However, it's of course one of the key things we want to focus on to make it better. So there is nothing perfect yet.
Thanks. If the listener doesn't terminate TLS, can we still control the certificate in the HTTP route, or does the traffic directly hit the pod and it needs to handle TLS? Second question.
Oh, no. It depends really on the protocol configuration. If you're using the HTTPS protocol, you're expected to configure a certificate. Then if you want to use pass-through mode, it's needed to use the TLS protocol. So there is no possible, yeah. It depends on the protocol used.
Okay, thanks. Why is GWCTL standalone and not bundled into kubectl?
Great question. I don't know. Maybe later.
Because you had to install GatewayAPI separately, right?
Yeah, for sure. Yeah.
So it's just because of that. Even the GatewayAPI spec is not part of Kube natively. I mean, as a standalone.
The top question is gRPC supported? Is there a static list of filters, or can we use custom filters like use mode security to create security rules per route?
Many questions in one. So gRPC is supported, yes, but it's experimental with a dedicated route. Can we use custom filter like mode security to create security rules per route? It depends on the, of course, on the GatewayAPI implementation. But of course, you could.
Thank you. Still the plan to get GatewayAPI merged into Kubernetes once innovation has settled?
I guess that's the plan, right? I mean, Ingress specs has been here for 10 years. It has been frozen for 10 years, basically. And so there is no way it will evolve in the future. So yes, GatewayAPI will get merged. We don't know yet when, but it's production ready. So, I mean, you can use it already.
Probably ties in the next question. Why is GatewayAPI not enabled by default in the Traefik Helm chart?
Maybe because by the past we enabled by default the Ingress one, and we didn't want it to make that decision for the user. That is for now. Maybe in the future we will change that position and maybe install by default the Kubernetes gateway provider instead of the Kubernetes gateway provider instead of the Kubernetes gateway provider, Ingress provider. Sorry.
Yeah, probably in the next major version or something like that.
Yeah, exactly. Yeah.
Is forward auth middleware still possible with Traefik Gateway?
Yeah, as an extended ref filter, right? And
yeah, sure.
Yeah, every middleware can be used as a filter, so it's totally possible. Yes.
Do you need multiple listeners for each hostname, or are wildcards possible?
Sorry, do you need multiple listeners for each hostname? Oh yeah, wildcards are possible, definitely. Yeah.
I think you probably had it on the slides.
Yeah.
The third one being, does it also support advanced request manipulation, like check a JOT token in the request, and if a claim is missing, route the request to a different endpoint?
So authentication is not part of the specs yet, right? It might, but JOT management is done in an extension ref filter. So it's dependent on the vendor implementation, okay? So I don't know what to say, but it's not part of the spec yet.
And the last three ones are, is only HTTP standard, which protocols will follow? Sure about this question.
HTTP and HTTPS, yeah. We are waiting for TCP. And
I think gRPC could be next.
Yeah.
It's probably in the project roadmap on GitHub.
Yeah.
Any tips on how to deal with issues in header-based routing in corporate firewall environments?
I guess we would need a bit more detail on this one.
We can also take it offline and...
Yeah, exactly. Offline is probably better on this one.
Is there anything planned to reuse matches definition in multiple HTTP route independent of the host name?
Not that we are aware of, but it will be a good improvement, yeah.
Okay, perfect. Thanks for answering the question and a great session. Thank you.
Thank you so much.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.